Hi everyone, this is part 2 of the lecture on conditional probability. We are looking at more examples, and I think we already looked at this example in the previous lecture. So I'm continuing with another problem that uses or expects us to understand better the idea of conditional probability. So I have the formula restated here so that we remember what formula we use to calculate conditional probability. So let's look at this problem. What is the conditional probability that a family with 2 children has 2 boys, given that they have at least 1 boy? Now, as we discussed in part 1 of this lecture, there is some additional information that's given to us, using which we should update what we know about this, right? Okay, so let's write down the events in this problem and assume each of the possibilities, so having a boy and a boy, boy and a girl, girl, boy, and girl, girl is equally likely, right? So B represents a boy, G represents a girl. So let's write down the events and based on that, compute the conditional probability of E given F, right? Which I've stated here. So E is the event that the family with 2 children has 2 boys, right? Because that's what my problem is asking me, right? What is the probability that a family with 2 children has 2 boys, right? So this is exactly what my E is. It has 2 boys. And F is the event that this family of 2 children has at least 1 boy, right? So now let me figure out what probability of F is and what is probability of E and F and plug into this equation and get the probability of E given F, right? So this is my F, that they have at least 1 boy, because that's what the problem asks me to do. Now, what do you think is the probability of F? We know that like in a family of 2, these are all the possibilities, right? So 3 of them out of the 4 have at least 1 boy, right? Except for this option where they're like both girls. So by our definition of probability, I know this is 3 out of 4, right? At least 1 boy, 1 or more. Okay, so what is probability of E and F? Which actually means that the family is of 2 children has at least 1 boy and 2 boys. So like how many of the given set of sequences match our sequence? Just 1, right? Which is both boy and boy, right? So that is going to be 1, and let me write down. This is the only set that matches our requirement. So that's going to be 1 over 4. Now we can plug in both these values into this equation to get probability of E given F, right? Which is going to be 1 over 4 divided by 3 over 4, which is 1 over 3. Okay, let's quickly look at another problem based on conditional probability, right? So out of 100 people surveyed in a study, 35 smoke, in which there are 20 males. What is the probability that if the person surveyed is a smoker, then he is a male, right? So if I'm saying M, that the person is a male, and S for smoker, right? So these are the 2 events. What I'm really trying to find is probability that the person is a male given that the person is a smoker, right? So this is important, like to formulate what exactly you're trying to calculate or what exactly you're trying to find out. So based on the formula for conditional probability, I should be trying to find the probability of S and the probability of M and S, right? Which is why I'm going to like plug that here, which is probability of M and S and probability of S. Now, that's easy to figure out in this problem. It's not that complex. We simply look at the frequencies, and that's what my event is. The total number of people in the entire sample is 100, right? So that is my sample space. And then there are 35 who smoke, right? So I know that. Now, people who smoke are male, That's also given. So this is a pretty straightforward problem. So out of the 35, 20 of them, sorry, this is from the entire 100 people. I'm sorry about this. Yeah, I started to solve the final equation. So this is S and M. So I'm going to plug both of them here. And this is going to give me 20 over 35. Yeah, I just jumped to this final equation here. Okay, another example to better understand this conditional probability. So a fair die is rolled twice to obtain two numbers, such that x1 is the result of the first roll, x2 is the result of the second roll, right? So we roll it twice. Now it's given that the sum of the two rolls is 7. What is the probability that x1 is 4 or x2 is 4, right? Slightly more complex than the two problems that we looked at earlier. Let's actually try to write down what our events E and F, or let's say I'm saying A and B are, right? So let's say my first event is A, and that event is when x1, which is the result of the first roll, is 4 or x2 is 4, right? So this is given, so we also have to figure out B, which is my given, right? And this is what I have to find out. A is what I have to find out, and B is something that's given to me. So what's given to me is that x1 plus x2 is 7, right? And what I need to find out is when is it that x1, what is the probability actually that x1 is 4 or x2 is 4, given that this sum exists, right? So basically I have to find out this. And for this, I should find out A and B and also the probability of B, right? I can actually enumerate that here. I know that when a die is rolled twice, the number of possibilities are 36, right? Because I'll have all these 1, 1, 1, 2, and so on up to 1, 6, and then each number up to 6, right? Because we have the numbers from 1 to 6 on a given die, right? So this is 6 times 6 possibilities, which is 36. So this is the total number of possibilities that I have. Now let me look at how many possibilities is A possible actually, right? So let's go and count those. So A is either x1 is 4 or x2 is 4. So it could be 4 with 1, 4 with 2, and so on with 4 with 6, right? And then it could be 1 with 4. So 4 could be the first one or the second one, right? And then all 6, 6 and 4, right? So essentially A will have like 12 possibilities, right? So let's write it down here. So there are 12 possible ways of having A, the cardinality of A in this case, right? So that's 12. Now let's look at the cardinality of B. Now B is saying whenever we have the sum equals 7, right? So it could be 6 and 1, 5 and 2, 4 and 3, and so on, right? So if I enumerate all of them, there are 6 of those, right? Why? Because this is 4 and 3, 3 and 4. Let me actually write all of them down so that we are clear that there are 6, 2 and 5, 1 and 6, right? So 6 of them. 6 of them have the sum equals 7, right? And when is it that A and B both occur? That means the sum is, 7 and x1 is 4 or x2 is 4. If we just look at these two sets, I can actually figure out it's 4, 3 and 3, 4, right? So A and B is going to be just 2 of those, right? 4, 3 and 3, 4. So just 2 of those, right? Now I can plug in all of this in the equation. I don't know if I have more space. Yeah, that's good. So I'm interested in finding probability of A given B, right? And that should be probability of A and B, right? Divided by the probability of B as per the formula of conditional probability. And this is going to be 2 over 36 because we figured that there are 36 total possible cases, and this is going to be 6 over 36 because that's what we figured, and this is 1 over 3. Let me quickly double check if that was the case, right? So this is 2 out of 36 and B is 6 out of 36. Yeah, so that's right. Let me also write down like what all those cases are. So this is 4 and 3 and 3 and 4, just to make sure that this is correct. Right. Okay, so this finishes our part 2 of the lecture on conditional probability. In the next video, I'm going to talk about the multiplication rule.